Good morning, my dear grade 10. How are you today? I hope that you are doing great. Okay, so today we're gonna continue Unit 1, Structure of Matter, Chapter 3, Ions, and we're gonna deal with Part 1, Definition and Nomenclature. The objectives are 1. Identify an ion. 2. Identify the type of ion. 3. Identify monoatomic, diatomic, and polyatomic ions. 4. Identify how are positive and negative ions formed. 5. Name monoatomic ions. And 6. Name polyatomic ions. Objective number 1. Identify an ion. What is an ion? An ion is nothing but an electrically charged chemical species. An ion then carries a charge which is either positive or negative. Example, Na+, N3-, S2-, SO3 2-, NH4+. How are ions formed? Ions are formed due to the loss or gain of one or more electrons by an atom to form a monoatomic ion or a grouping of atoms to form polyatomic ions. For monoatomic ions, monoatomic ions are formed due to the loss or gain of one or more electron in an atom. This means ions come from atoms that have lost or gained electron in order to satisfy the octet or duet rule and become stable like its nearest noble gas. Why are ions charged? Ions have or carry a charge because the number of protons in their nucleus is no more equal to the number of electrons in their electronic cloud due to the fact that atom loses or gains electron in order to produce ions. So that when electrons are lost or gained, then we can say that the number of electrons are no more equal to the number of protons, so that the chemical species is no more an atom which is electrically neutral, but now it's an ion which is electrically charged or simply charged. Objective number 2, identify the type of ions. So we have two types of ions, cation or anion. A cation is an ion with a positive charge, and an anion is an ion with a negative charge. And you can realize here the T in cation stands for plus, positive, and the N in anion stands for negative. Objective number 3, identify monoatomic, diatomic, and polyatomic ions. A monoatomic ion is an ion formed from a single atom only. Example, Ca2+, Na+, Cl-, N3-, S2-, Al3+. As you can see, in each of these ions we only have one single atom in the structure, if you want, okay? If an ion contains more than one atom, it's then called a polyatomic ion. Example, CO3 2-, SO4 2-, PO4 3-, and H4+. So as you can see here, we have a grouping of atoms that carry a charge. Okay, in general, in a polyatomic ion, the grouping of atoms is made of a grouping of non-metal that has a charge. Okay. If an ion contains two atoms only, it's then called a diatomic ion. Example, OH-, you see we have the atom O and atom H, the whole grouping carry the negative charge minus, 1-. ClO-, Cn-. Note, in a polyatomic ion or diatomic ion, it's the whole grouping that has either lost or gained the electron to form that polyatomic ion with a charge. Objective number 4, identify how are positive and negative monoatomic ions formed. A cation, positive monoatomic ion, is formed by an atom that has lost electrons. A monoatomic anion, negative monoatomic ion, is formed by an atom that has gained electron, of course, to satisfy octet or duet rule. But metal lose electron, as you know, and non-metal gains electron. Hence, cations are produced from metals that loses electron, whereas non-metals gain electron to form negative anions. Positive polyatomic ion, yani cations that are polyatomic, are formed when the whole grouping loses electron, while negative polyatomic ions, polyatomic anions, are formed when the whole grouping gains electron. And here we have a table. You can see when a neutral atom loses electron, it forms a positive ion. When a neutral atom gains electron, it forms a negative ion, which is no more electrically neutral, okay? Rule for metal which produce cation. Here when we have an atom which produces monoatomic cations. When a metal X with one valence electron loses its one valence electron, it forms an ion with 1 plus charge. If you remember, the symbol is simply X to the power 1 plus, like Na plus, for example. When a metal X with 2 valence electron loses its 2 valence electron, it forms an ion with 2 plus charge, symbol X to the power 2 plus, like Ca2 plus. When a metal X with 3 valence electron loses its 3 valence electron, it forms an ion with 3 plus charge, symbol X to the power 3 plus, like aluminum, Al3 plus. Same for polyatomic ions. When the whole grouping loses one electron, then this polyatomic cation has a 1 plus charge, okay? When the whole grouping loses 2 electrons, then the polyatomic cation will have a charge 2 plus. And if the whole grouping in the polyatomic ion, if the whole grouping loses the 3 electrons, then the polyatomic cation will have 3 plus charge, okay? The polyatomic ion formed will have 3 plus charge. For non-metals, atoms that are non-metal which produce the monoatomic anion, negative ion, when a non-metal X with 7 valence electron gains 1 electron, as you know, it forms an ion with 1 minus charge, symbol X to the power 1 minus, or X1 minus, or X minus. When a non-metal X with 6 valence electrons gain 2 electrons, to complete its octet, it forms an ion with 2 minus charge, symbol X2 minus, like O2 minus, S2 minus. When a non-metal X with 5 valence electron gains 3 electron, it forms an ion with 3 minus charge, symbol X3 minus, like P3 minus, N3 minus. And example for X1 minus is Cl minus, Br minus, F minus, I minus. And of course, same for polyatomic ions. When a whole grouping gain 1 electron, then this whole grouping will produce a polyatomic anion with 1 minus charge. When the whole grouping gains 2 electrons, it will form a polyatomic anion with 2 minus charge. And when the whole grouping of non-metal gains 3 electrons, then it's gonna form a polyatomic anion with 3 minus charge. Objective number 5, name the monoatomic ion, specifically here the monoatomic cation, monoatomic positive ion, which comes from metals. Monoatomic ion, positive ion cations acquire the same name as the atom they come from. And here we have some common monoatomic ions. We see the ions that are produced from the element, from the main group elements, okay? Main group elements, you know, they are the elements of column 1, 2, 13, 14, 15, 16, 17, and 18, whereas the elements of column 3 to 12, as you know, they are not the main group element, they are the subgroup elements. So here we have a table that shows the cations that are formed from elements of column 1, 2, and 13. We have here Li plus lithium ion, Na plus sodium ion, K plus potassium ion, Rb plus rubidium ion, the same name as the atom they come from, and you add the word ion. Cs plus cesium ion, Be2 plus beryllium ion, Mg2 plus magnesium ion, Ca2 plus calcium ion, Sr2 plus strontium ion, Ba2 plus barium ion, and Al3 plus aluminum ion. Here we have another table. Okay, we have some repetition of the main group, the ions formed from the main group element, and some other ions, cations that come from transition metals. Okay, and here we have in the first table hydrogen ion H plus. So here again we have another table, as I have told you. We have the charge, the formula, the name, the cation with 1 plus charge. We have the hydrogen H plus, it's the acidic hydrogen. Okay, Li plus lithium, Na plus sodium ion, K plus potassium ion, as we have said, Cs plus cesium ion. Now we have Ag plus silver ion. Now the one with 2 plus charge, Mg2 plus magnesium ion, Ca2 plus calcium ion, they are very important, Sr2 plus strontium ion, Ba2 plus barium ion, Zn2 plus zinc ion, okay, Cd2 plus cadmium ion, and the Al3 plus aluminum ion. Now we have other common monoatomic cations that you have to memorize. Of course, these monoatomic cations, they are very common, they are very important, and you are going to see them very frequently, so please memorize their name and their symbol. Now when you have some atom have two ions, okay, like iron for example, we have Fe2 plus, Fe3 plus. In general, either you can name it as, for example, Fe2 plus iron 2 ion with 2 in Roman number, or ferrous ion. Fe3 plus, either you call it iron 3 ion or ferric ion. Usually the more positively charged, okay, take Ic at the end, and the less positive take, for the same atom, take OUS at the end. Okay, now we have Cu plus, either you call it copper 1 ion or cuprous ion, Cu2 plus copper 2 ion or cupric ion, Pb2 plus lead 2 ion or plumbous ion, Pb4 plus lead 4 ion or plumbic ion. Now for the monoatomic negative ion. Monoatomic negative ion, anion, ends with "ide" by subtracting the last 3 letters of the non-metal they come from, and then you simply add "ide." Here we have common monoatomic ions to be memorized. They are very important. Okay, at first we have those of the main group element. Main group element, as we have said, they are the elements of column 1, 2, 13, 14, 15, 16, 17, and 18. And as non-metal gain electrons, then they're gonna be elements of column 16, 15, 17, and we have carbon and column 14. Of course, noble gas are stable, they don't form ions. So here we have fluoride F minus, you see fluorine becomes fluoride, Cl minus, chlorine becomes chloride, Br minus, bromine becomes bromide, I minus, iodine becomes iodide. And we have the hydride ion, it's H minus. Of course, as exception, hydrogen is the only non-metal to the left side of the step line in column 1, but it doesn't belong to this family, it's not an alkali metal. When bonded to metal, it forms H minus, and acidic hydrogen, it's H plus, okay? Now we have elements of column 16. Oxygen becomes oxide ion, O2 minus. Sulfur becomes sulfide ion, S2 minus. Elements of column 15, nitrogen becomes nitride ion, N3 minus, and phosphide becomes P3 minus, phosphorus becomes P3 minus phosphide ion. And we have the carbide ion, C4 minus. Now we are going to move to the polyatomic ions. And we're gonna start with the polyatomic cation. We are responsible of only these two, H3O plus, the hydronium ion, and NH4 plus, the ammonium ion. Now we start with the polyatomic anion, and specifically here we have at first the diatomic anion. We have the ion of the base. It's very important. It's OH minus hydroxide ion, Cn minus cyanide ion. Okay, they are diatomic ions, these ones. ClO minus, it's the hypochlorite ion. Now we continue with the polyatomic anion, and now we have the 8-ite pairs. Usually in the 8-ite pairs, the more oxygenated ends with 8, as you are going to see, and the less oxygenated, the one which contains less oxygen, ends with ite. We have the following pairs: NO2 minus and NO3 minus. Then NO2 minus, less oxygenated, it's nitrite ion. NO3 minus is its nitrate ion. PO3 3 minus and PO4 3 minus. Then we have PO3 3 minus, phosphite ion, PO4 3 minus, phosphate ion, SO3 2 minus, sulfite ion, SO4 2 minus, sulfate ion. You see, you have everything is the same, the charge for the pair 8-ite, but the one of them is more oxygenated than the other. The less oxygenated ends with ite, and the more oxygenated ends with 8. So if you memorize nitrate to be NO3 minus, then the nitrite, it's NO2 minus. You remove one oxygen. If you memorize the PO4 3 minus phosphate ion, then the phosphite ion is gonna be PO3 3 minus. If you memorize SO4 2 minus, the sulfate ion, then simply you say that the sulfite ion is gonna be SO3 2 minus. We have other important polyatomic anions. Okay, all of these are to be memorized. CO3 2 minus is the carbonate ion. MnO4 minus, MnO4 minus, it's the permanganate ion. And Cr2O7 to the power 2 minus, it's the dichromate ion. Now we have here some other polyatomic anions. We have the hydrogen sulfate, they are very important, HSO4 minus, hydrogen phosphate, HPO4 2 minus, dihydrogen phosphate, H2PO4 minus, hydrogen carbonate or bicarbonate, HCO3 to the power minus. The oxalate ion is found in tomato, C2O4 2 minus, and the acetate ion is found in acetic acid, CH3COO minus. So these are the ions you are responsible for, and thank you very much.